So if we do what they talked about in the little PowerPoint here, just copy and paste that. And then steal stuff. There we go. So you can even see right here, I'm gonna do 1, 2, 3, 4. This is context of 4, 4, 4. So right here, this doesn't compile. And this doesn't compile either. Both of them, it's because it was outside of the initialization. So that's the key part there. But it's fine when you're actually initializing it. So that's just different syntaxes there. Okay, so accessing elements in an array. So now just assuming we have this right here, we've got the little visual here with the indice and the value of this array. So if we wanted to get access to the first index, so that's the second value in it, we would do ARR1, and that gets 9. It's not 5, because again, that's really trying to push the point of it. It doesn't start at 0, it starts at 1. So you really need to know that. And same thing here for 5, 0, 1, 2, 3, 4, 5, 37. So this would print out 37, this would print out 9. And so that's not just for accessing the information, it's also for modifying the information. So here we got our array, got our little table. If we say ARR2 equals 18, 0, 1, 2, so this is now 18. And then 7 equals 50, 1, 0, 1, 2, 3, 4, 5, 6, 7. So this is now 50. And down here you see 18 and 50. So that would actually happen inside your array. So if after here now, you wanted to do system.out.println ARR2, you would get 18. Okay. So I mentioned it a little earlier with this array, but here it's a little more explicit. We talked about some of, oh yeah, it even mentioned right here. It would give you an array of 3 zeros, but like you didn't explicitly say that, but that just happens because of the default values. And so here we have a double, a Boolean, and a string. So the double array starts at 0. So that these are all length 1 arrays. So at index 0, it stores 0.0. That's the default value for a double. Here, Boolean is false, the default value for a Boolean. And then here, it's null, the default value for a string. I said strings were a little unique, not really primitive. So that's why they don't have a default value like that. The default value isn't just an empty string. It is just null. But for every other primitive, so not strings, but any other basic thing like an int, long, character, all of those start at 0. Though for a character, it's not the letter 0, it's the actual 0 value, which technically translates in a string to null. But you don't just know that it's, if you cast it to an int, it'd be 0. Okay, so what actually are arrays? So knowing what arrays actually are, so all we've talked about so far was arrays by themselves, like a single array and then just modifying it itself. Now we're going to talk about what happens when you assign one array to another. And so knowing what arrays actually are helps for that. So we talked about how it's just a bunch of values right next to each other, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But in memory, they are literally right next to each other. So in however you think about your computer stores information, we haven't really got into that yet. Just know that arrays keep everything like in memory physically right next to each other. And that property makes it really efficient to access information and change information. There's some things that aren't as efficient. You'll get into that programming too. But just know that there's a reason why that's super efficient. How they're actually stored when we say int array equals new int 3. is that ARR here stores the memory address of the first index, of the 0th index, so the first value. So it just stores the memory address of that first one. And so how it gets access to all the other elements is when you do square brackets and then a number, it adds that number to the memory address and gets the value there. So that's why it starts at 0, because it adds 0 to the memory address and gets the value there, or adds 1, gets the value there, adds 2, so on and so forth. But the downside to that is arrays act a little differently than you're used to with variables. So when we say int a equals new int that 1, 2, 3, and then int b equals a, int array b equals a, they are now actually storing the same memory address, the same location in memory. And so if you say b0 equals 5, changing that 0th index, now since both of them are storing the same memory address, and this is saying add 0 to the memory address and change the value there, these are both going to be printing out the same thing. So if we copy this, put it in here, and then fix it because it doesn't like the enter for whoever used it. Okay, so with that, yes, run this. So I know it has a little comment there saying it, but I just want to make sure you guys see it. 5 and 5. 5. Another thing that I want you to see is what happens if you just print out A and B by themselves. So if we take this and run it. So right here, this random collection of stuff, you don't need to know this. This is definitely more advanced for you guys, but I just want to show you that it's a random bunch of numbers. You don't know what they mean, but they're the same. And the stuff before the numbers is actually just a thing that Java uses to keep track of information. But the numbers themselves are a memory address. And one thing you might be able to notice is that they're in hexadecimal format. Again, you don't need to know that. You never really need to work with these memory addresses in Java, but they are the same. And they're storing a number that's representative of the memory address. So that's why if you do b equals a, b0 equals 5, that messes with a. And so that's really unique from when you're dealing with primitive data types, because they're not stored that way. If you just printed out a primitive data type, it would print out its value. But with an array, if you just print out the array, not a specific index, it prints out that memory address. And you're going to see that a lot more in programming too, because in C++ you can actually deal with those memory addresses. But in Java, you're not really supposed to. It kind of wavy hands magics away a lot of that. But you'll need to know it, because when we start talking about like passing by reference or passing by copy, primitive data types in terms of functions and function parameters. So if you write a function, void return type, I don't care, call it fake, sure. And then in here you did int x, and then you did x equals 5. You all should know that by changing x, you don't change what's outside of it. So you pass in a value, it doesn't change it. But if you did int array x, and then you did x 0 equals 5, that's the same things we did down here, where we said int b equals a, and then b0 equals 5, and then you print out both of them. It changes the other one. So this will actually change the thing that you passed in, because it's passing a memory address. I found that concept really helps a lot of students, and we don't really talk about it in programming 1, so that's why I'm emphasizing it a little bit. If that doesn't really make sense to you, don't worry about it. Just know that arrays pass by reference, and that means if you do a change to an array, it changes what's passed in, and then primitives don't, they pass by copy. But if that doesn't make sense to you, then glad that helps. Okay, not there. Here we go. Yes. Okay. So using arrays and methods, just the thing I talked about a little bit. Since an array is a memory location, Yeah, point. Yeah, C++. So an array points to a location in memory. Primitives don't do that. Arrays do that. So we just went over that. If you change a past in array, it changes. If you change a parameter array, it changes the past in one. Not true for copy though. So yeah, then right here, it's talking about just like calling the function, then after the fact, what those values will be. And so the array does get changed into 369. Factor does not, it's still 3, even though we changed multiplier. Okay, so using arrays, we've talked about like how to initialize one and assigning one to the other. But now what if you want to use all the information in an array? That's like the next thing to talk about. If you're ever told to like do something to each of the elements, your first thought should be a for loop. Because for loops are really great if you know the size of whatever you're looping through. And arrays you always can in Java by using array.length. So you might have seen that for like strings already. I think they have a .length. Same concept. It gives you the length. But remember, the length of this is 10, even though it only goes till 9. So that's why we do I is less than array.length, not I is less than equal to. That's the key fact for that. Now that we've talked about arrays, just I understand what they are, we can talk about some new loops. I'm assuming you haven't heard of them. So we've done a for loop. I is less, so if we had like an array. Sure. To do a for loop through it, you do r.length. You can still do a while loop. They even showed an example of it in the presentation. I'll hop back to in a second. But if you do int I'll do j now, j equals 0, while j is less than r.length, and then j plus plus. So it's basically the same thing as this for loop. Though arrays do give you more control, like this j plus plus could be anywhere in the code. You could do stuff after it, whatever you want. So while loops do give you more control, but usually a for loop is shorter. Then we mentioned a do while loop, which is going to be the exact same thing as above, except now we start with a do first, God, and then end with the while. And then here we do k plus. And so this one's same as the while loop, except the condition gets checked at the end, not beginning. So I personally, I don't think I've ever used a do while loop. I just prefer a while loop. But it is something you have access to. But now the last loop, you type in for, so for and for I, they do the same thing. And actually for each looks like a for. So for I and for each are both for loops. So syntactically, they just start with the word for. But for the shorthand for I here, this fills in a lot of stuff that you would have to do if you were declaring a for loop in most languages. Like almost every language with the for loop has these components, these 3 components. However, people realize that with arrays, you usually want to go through each element of the array. And so a for each loop is more of a shorthand for that. And so here, you do declare something. I'm going to say int k a, sure. And then on the right side of the semicolon, you put your array. And so here, if we system.out.println a, so now here a just gets assigned to each element in our loop one at a time. So you don't have to do array I or array something for each element. This just makes it a, so for this for loop, first it assigns a to the first element, does it, then the second one, then the third one. So it's for each element of the array, do this. That's kind of what the logic is for that terminology. Again, this doesn't give you much control. Like if you wanted to skip over elements or something, you couldn't do it. You really got to go through each of them, unless you have like an if statement built in or something, which is valid. But for loops have that in general. The most basic loop is a while loop, and then a do while loop, just because it's the same as a while loop, but you check at the end. And then a for loop gives you a little more control because you can choose a starting value and then whatever your increment wants to be in there. And then for each loop has the least control, but this is way easier to type out. Like it's very quick, just do for each int a AR. And that's all the loops you have access to. Whenever you get an array, you should probably initially think of a for loop, be it for each or a normal one. You can use a while loop. There might be some situation where you'd want a while loop over a for loop for an array, but most of the time, a for loop is what you're looking for. Okay, so I talked about all the new loops. So yes, we talked about array.length. For each loop right here, and you don't put for each there. So you don't, it still just says for, it doesn't say for each. So the shorthand just does that, the shortcut. Strings can be done in a similar fashion. So if this was a string instead. However, so if it was a string, hello. Is it not dot length? So now with strings, it's got little brackets there. So make sure you know that distinction. And then for each loop, so you might think that a string is just an array of characters. That is a wonderful way of thinking about them. But even if you put character A here, for each loops don't work with strings. So you might not be able to read that, it might be really tiny, but it says for each not applicable to type java.lang.string. So for everything else, you could do almost the exact same thing except changing length to length with the brackets because it's a method now, not an attribute. But for each loop, you just can't. Okay. Question. For each loop specific, yeah, arrays. Yeah, other way around. For each loops apply to arrays. I wonder if there's anything else that they apply to. We can go look at that. So it looks like there might be some other arrays they work with, like array lists. Oh yeah, and if you change num, it doesn't change the num in the array. That's a good key point. Because it's no longer dealing with the memory address anymore. It's saying num equals the value in the array. So it's no longer dealing with memory addresses anymore. Because an array, those values in the array, those aren't connected. They do have a memory address, but if you say a new variable equals one of them, changing the variable doesn't change the array. It's only if you say array 1 equals something specifically that changes the array itself. So that's for each loop. Didn't say anything there. Yeah, I can't find this, but yeah, definitely it's for you guys. You just need to know that for each loops only work with arrays for now. That's that, and not strings. Any other questions on arrays? You guys will have to use it a lot in Project 2B, so it'd be really good to like fully understand what's going on there. Cool. Okay. So some practice problems. Not going to go through all of them. Like last time, I think I just turned off the computer. So sorry, you in-person people. That's going to take a hot minute to come back online. If ever. getting power, and then the power button for the computer right there, turn on, there you go. Sorry guys, I just turned off the power for the in-person people. Oh, that's so sad. I don't know how to turn you back on. All power buttons. That's an F. I don't know how to turn the thing that connects these to here back on. I will probably have to call someone at some point. Just join. Are you on the Zoom? Both. Yeah, just get on the Zoom. I'm so sorry. Okay. Angelica, I already see you're on the Zoom. And I just, let me. Yeah, because the computer's turning on. Just press my button. Okay, well, Anna, you're on the Zoom now. I'm gonna keep going. I don't even know how to turn the projector off without this little shenanigan thing over here. Okay. So yeah, I'm not gonna go over each of the practice problems, which is kind of what you should be thinking about when you get it. So for number one, given an array of numbers, determine the parity of numbers, odd or even, which parity of numbers odd or even, or if there's an equal number odd or even. So you have to keep track of a number of something. So you'd want like 2 ints like num odd and num even to keep track. Definitely a for loop in this case. It could be a for or for each loop because you want to go through all of the elements. But so either for the fors work. And then for odd or even numbers would be num modulo 2 equals 0. And then odd would be num modulo 2 equals 1, like that. So that's those things, and then some sort of comparator like less than, equal, or greater than for those after the loop's all done. So those are the kind of things you should think about when you're writing it, because those are all like the requirements to get it done. However you put them together, that's up to you. Okay. And then for number two, given an array of numbers and a target value, determine if the target's negative counterpart exists in the array. So negative counterpart is just the number times -1. So first you have a number, so you'd want to do like int negative equals num times -1. So you'd want to get the negative counterpart. And then since you're going through each of the elements, again, for loop or for each loop is fine. And then as soon as you find this number in there, return true. So if you go through the loop and find the number, just instantly return true. But if it goes through the rest, if it goes to the loop and you don't find it, then return false. So that would be outside of the loop. My R's and my N's look very similar and it doesn't work. So yeah, this would be inside. This would be outside. So something like that. So that's pretty short. That's really nice. The last one I am going to show you the demonstration for, just because there's one thing that this could trick you up with very quickly. So we go to here. And okay, so let's say we have our integer array, int array equals 1, 2, 3, 4. And then we say for, I'm just going to do a for each. No, I need for. This has to be a for loop because I'm modifying the array. For each loop you couldn't modify it with. Int I equals 0, I is less than r dot length plus plus I. So here I'm going to do ARR and then ARR dot length -1 minus I. So what I just did there, ARR length dot length -1 gives you the last element. So if I just did this, that would give me the last element in the array no matter what. That's what ARR dot length -1 does. And then minus I, if I start at 0 and go to ARR dot length, so this is saying I is 0, then 1, then 2, then 3. I'm going to go through all the elements in reverse order using this. So that's really useful. And so you might think to reverse it, you just go in reverse and assign it to the value that's in the right order. So for this one, it's going to go in reverse, starting 4, 3, 2, 1. And then this one's going to go in the right order, 1, 2, 3, 4. So that's going to assign the last value to each of the first values. And if we do another for loop, exactly like this, and then print out system.out.println ARR I. This should print it out in the correct order, and it should be reversed after we do this. Well, if we run it, you'll notice that that is not in reverse order. It's not even, the 3 and 4 just got completely lost in this instance. And that is because when you wrote this, and you had 1, 2, 3, 4, right here, this was saying last index equals 1, and then second to last index equals 2, and then the next one, the third to last, is now equal to the third, and that does not work because now it's assigning 2 to 2 and then finally 1 to 1. So because we were modifying the array as we were trying to use those values, we just overwrote some values we needed. So instead, you need some sort of intermediate array in here. And so if we do int temp equals array equals int array dot length. So I just made another array that has the same length as I just made another array that's the same length as this one, and you can use a variable in there that's true in Java. So now with that, I'm going to say temp array.length minus I minus 1 equals array I. And then I'm going to say for I less than array.length. Array I equals temp I. So with that, I can say, I can do this in the right order. So I assign it to the temp array first. So now there's two completely separate arrays that I put the right value in the right order. And then I overwrite the original one with the new values. And then I print it out. So running this. 4, 3, 2, 1. And that's what we wanted. So all that was just to show you how to like make a temporary array. So you modify, you assign to that temporary array and not overwrite what you're doing until you want to overwrite it. Okay, and I remember if I had done temp equals ARR and done this, we would have ended up with the same thing because now temp and ARR are pointing to the same memory address. And so changing one changes the other. So that could be some way we could trick you. Okay, cool. Any questions on arrays? Cool. Okay. So the next thing we're going to talk about is the lab. So the lab this week goes over a lot of stuff we covered last week with numeric conversions. So you guys use this on your tests. You guys talk about it in the lab and maybe had a quiz on it, converting numbers somewhere maybe. Either way, you've definitely had to convert numbers from one base to another at some point along in the class at this point. Well, now you have to actually write the code for it. And you also have to do this in your project. So again, focus on the project first, and then this might be a little easier after. But the goal for it, anytime you have to do some sort of algorithm on a computer that you've done in your head first and can like write down, is you want to find a way to turn your written algorithm into a computer algorithm. So break it down into the most basic steps that can go one step at a time, doing one singular thing. And that's what you would write in code. So however, like I personally have my method, which we covered a lot last time. You can watch the video for that. Where like if you had some like decode hexadecimal, actually the decode hexadecimal and binary, that's a really easy, not, okay, obviously it's not easy, you still gotta do it. But if you're given something like 6AE, then you do the, the way we broke it down, here, I'm gonna, the way we broke it down is if you had 6AE, you would do 6 times 16 to the 2 plus A is 10 times 16 to the 1 plus E is 14? A, B, C, D, yes. Times 16 to the 0. So we would write that out and then we do the math. I'm not going to do the math. But we write that out and solve it. So with this kind of thing, let me use a different color. So this, and this kind of look really familiar, like they look really similar. And so that would be a good thing for a loop. So you'd have like sum equals 16x squared, and then sum plus equals 10x 16 to the 1, and then plus equals, yeah, so you could do that. And then you might see like, oh, hey, this starts at 0, and then 1, and then 2. That would be perfect for a for loop. And so going, okay, for loop 0, 1, 2. How do I use that for loop with this string? Yeah, Ariana, you're correct. That would be a string, so you have to parse through it. So since you know you have to parse that string and you got the 0, 1, 2, that is really good. So you might want to start your for loop at 0 and then go to 2. So then if you had more, it'd be like 3, 4, and so that would be length minus 1. So that's perfect for that. Really fits in nicely. However, if we had more numbers, like 7, D7 something, sure. The way indexing works, it's 0, 1, 2, 3, 4. So you're like, how do I reverse this? Well, we covered the reversion process where you do, if you, even with the string it works. If you have some sort of string variable, maybe, I don't know if square brackets worth or not, but you still have character at, do that char at, and then string var dot length, and then I don't have any more space, -1 minus I. Oh, that's in the bracket. Minus I. There we go. So something like that. We talked about how to reverse, to go in reverse order. So you can use I as 0, 1, 2, and then the indexes in reverse order, something like that. However you want to do that is fine, but just the process of like any algorithm you can come up with can probably be turned into code. So think of the algorithm first that you understand and start breaking it down into its components. So we kind of just went over the hexadecimal one here, but you also have to figure out the binary one, which should be very similar. And then you also have to convert binary to hexadecimal. For that, you could go binary to decimal and then decimal to hexadecimal, if that makes sense to you. If you know that algorithm, the best thing to do is to do the algorithm you would want to do personally. But we also talked about like that shorthand for binary to hexadecimal. You chop up the binary into sections of 4, and then convert those sections of 4 to hexadecimal and then add it all together. That would work really well in the string format. But whatever method makes sense to you, like if you understand the algorithm like handwritten, there's a way to convert it to programming. So that's where to start. As for the actual functions you need to make, they're right here. You need to have these. We could be testing you. Some of the unit tests might use them specifically without calling the main method. Is there even a main here? Oh yeah, no, there's a main and stuff. Yeah. So there's definitely a main. So you have to have these methods. I don't know what that asterisk is there for. And then also keep track of this note down here that you should be able to handle if the string starts with 0x or 0b. And so that would just be a quick check at the beginning to see if the first 2 elements are 0x and 0b, and if they are, skip over them or something. But yeah, it's a looping menu. You've done that plenty of times. And then the algorithms for converting hexadecimal to binary, hexadecimal to decimal, binary to decimal, and then convert binary to hexadecimal. Honestly, I think this is going to be easier than your project. So again, if you get the project done, hopefully that's a little easier. Any questions on the lab? Ariana, I think I answered that when you asked it the first time, but I'm just confirming. If I didn't, let me know. Okay. Last but not least is your project. So your project, part 2B, is you will complete the first 6 methods on page 3 of this document. So the first 6 methods, 1, 2, 3, 4, 5, 6, it might not make sense what they do now, but just go through them one at a time. Just do the first one, then the second one, third, fourth, fifth, sixth, and just do what it says, and then try to figure out how they fit together in the actual options. I'm going to talk about it in a second, but these are the functions you have access to as you're working through it. So if we go to here, and then files, and then, oh no, yeah, you guys have access to it in assignments. And then project 2A, there we go. And then document in the folder. So here's all the documents you have access to. They're all useful in their own way. So the pre-work had you could do some stuff. So these functions just might be able to help you in general if you want to do them. I don't even know what that is. I think that's for a setup. Graphical output, just to see what it's supposed to look like. Image files, and you have to load a test image. The actual assignment file. Text output for what that's supposed to look like. Yeah, the console GFX. Where do I want? Here we go. This is what I want. Okay, right here. So here are the different options people can choose. So if they say option 3, 4, or 5, then they give you some sort of string. The user always gives you a string. And then depending on what string they give you, you have to call certain functions on it. So the one that you always call first is your string to data function. That's the only one of these functions that takes in a string. So the string to data function turns the string into a byte array. Just flat out, whatever string you're given, turn into a byte array. No semicolons, just straight up 3. So 3 is 3, F is 15, 6, 4, just one after another. And then from there, depending if you're given a flat string, then you want to end up with flat byte data. So that's perfect. But if you're given an RLE hex string or an RLE string, then depending on which one, you might, so decode RLE, that would be for an RLE hex string. I think that's the only, yeah, because you're not doing the other one yet.
So I have a question.
Yeah, string to RLE would be this one. So yeah, you're not doing that one yet. But you could do option 4, option 5 with the string to data function. And then once you've got an RLE byte array from option 4, you would pass it in to decode RLE, and that would make your flat data array. So then both of those would have you, so for input, the byte array is the maximum 15? Yes, because we're using hex numbers. So yeah, depending on which option, you might call 1 or 2 functions to get to flat byte array. And then from there, if they want to display the flat string, then you just call which one of these returns a string? Here we go, to hex string. So if they want the flat data, which was option, what was that? Option 9, then you just pass it into there and print that out. If they want option 7 or 8, then you first have to convert the flat byte array to RLE byte data. And that one is encode RLE. And then finally, again, you won't have to do the RLE string yet, but you could do RLE hex string, which is 2 hex string from the encode RLE. So pass this into 2 hex string. So you don't really need to think about where they all connect yet. I would highly recommend just getting them done first and then thinking about what the options do. But yeah, this one is really straightforward. Just get these 6 done, and then you can worry about like which options you want. But definitely get those 6 done first and behave how they talk about here. And yes, the maximum number in the byte array should be 15, though a byte can go higher. So you could end up storing a bigger number. Don't do that. It needs to break down into smaller ones. Okay, any questions on that? Okay, so technically that is where we end today. I do need to go to the restroom, so I will be back. You are free to leave, but afterwards I'll be going over questions, and I can go like more in depth to any one of these options. So look over the options, stick around if you have any questions, okay? Cool. Stop recording.